Welcome to Brain Vision.
Once again, welcome to a new set of chapter problem. This time, we're going to be dealing with momentum and motion problems involving mass and velocity. So, in this chapter problem, we're given uh, two vehicles. Like a pickup truck, which we're going to call MA. So, it has a mass of um, 2,500 kilograms. That's what we're given. And then also, we're being told that the pickup truck is traveling east-west. So if you think about directions, your east-west direction looks like this. So this is north-south, this is north, and this is south, and then east-west. So the pickup truck, 2,500 kilograms, is traveling westward. And then also, there's another sedan which happens to be 1,500 kilograms, and I'm going to call that MB. And the mass of the sedan is 1,500 kilograms, and it happens to travel uh, south to north. So the sedan is traveling upwards, south to north. Assume also that the positive x direction is that way, and then the positive y direction is upwards. So those are the assumptions that were given. Um, the pickup truck MA is traveling at a velocity, excuse me, VA, that happens to be 14.0 meters per second. And then the sedan is traveling at a velocity that happens to be 23.0 meters per second. So that's the information we're given. In terms of diagramming, you can assume that the pickup truck, the sedan, is traveling north-south. So if you had an x-axis, positive x-axis, and positive y-axis, the sedan is traveling north-south, so it's going upwards. If this is the middle, it's going to be going upwards like that. And that's A, that's the sedan, which I'm calling A. And then also the pickup truck is traveling westward that way. So you can see eventually there's a potential of having a resultant momentum. Remember, this is a momentum problem, so we're dealing with masses and also velocities of different vehicles. So that's what we're given. In part A, we want to find the x and y components of the net momentum. So we want to find the x and y component of the net momentum, which we're going to call P. And then that's just part A. In part B, we want to find the magnitude and direction, of the net momentum. So that's our goal and target. We want to find the magnitude and direction of the net momentum. So we're going to start with part A, and we'll deal with the pickup truck, and then we'll deal with the sedan. So for the pickup truck, we have uh, two types of momentum. So we're going to call Px, that's the momentum of the pickup truck in the x direction. And so PAX, we want to call it PAX because we have A happens to be the pickup truck. Okay, so A is the pickup truck. Okay, pickup truck. So in this problem, in the x direction, PAX, remember positive x is towards the right, and then negative x is towards the left. And the pickup truck, as you can see, it's moving towards the left that way. And so we have to find that momentum. If it's moving towards the left, it's going to be negative momentum. So negative ma times the velocity of a, which is obviously in the x. You could call it, xa or just a. If we plug in the numbers, we get negative. The mass happens to be 2,500. Okay, so our mass is 2,500 kilograms times the velocity, which is 14.0 meters per second. And so we have a momentum of negative 35,000 kilogram meters per second. And that's the momentum in the x direction for the pickup truck. So I'm just going to call this negative kilogram meters per second, like that. And that's in the x direction. The next thing we want to find is the momentum for the pickup truck in the y direction. Remember, the velocity, it's just ma times vya. That's the velocity in the y. But this time it's going to be, we don't have a sign. Because the velocity in the y happens to be 0. So this is 0 meters per second. So if we plug in the numbers, we get 25,000 kilograms times 0 meters per second. And so momentum in the y direction for the pickup truck is 0 kilogram meters per second. The next part of the problem is and I'm going to do that on the next page. That's the B, and the B is the sedan. This is the sedan. So we'll get the momentum in the x direction for the sedan, and that happens to be in the x direction. Remember, the sedan is moving upwards. If you go back, you can see the sedan right here. It's moving upwards. So we have the mass of the sedan times the velocity of the sedan in the x, which we're going to call xb. But this is 0 meters per second, because if you go back and check, you see that the sedan is moving in the y direction, but it's not moving in the x direction. So we don't have any vector velocity in that direction. The mass of the sedan happens to be 1,500 kilograms. So we're going to plug in those numbers. So 1,500 kilograms times the velocity, which is 0 meters per second. And that's going to give us 0 kilogram meters per second. In the y direction, the sedan is moving upward, so we're going to get a positive momentum, vyb. The mass of the sedan is 1,500 kilograms. The velocity in the y direction is positive. This is a positive velocity. And if you go back, you see that velocity is 23.0 meters per second. So we have 23.0 meters per second. And if you plug in the numbers in your equation, you end up getting 34,500 kilogram meters per second. The final requirement of the problem that's in part A, was to find the x and y components of the net momentum. So the net momentum, we're going to call that P net of A and B. And so P net of A and B, the first one would be the net momentum in the x direction. So the net momentum in the x direction, that happens to be, we're going to call it P x AB, and that is simply the sum of the momentum for A and the momentum for B in the x. For A, the momentum in the x direction, as you can recall, happens to be negative 35,000 kilogram meters per second. So negative 35,000 kilogram meters per second. And then for B, it's 0 kilogram meters per second. And so in the x direction, the resulting momentum for A and B is 35,000 kilogram meters per second. In the y direction, the momentum for A and B, that's the net momentum, is P YA plus P YB. PYA, if you go back, you see it's 0 kilogram meters per second, 0 kilogram meters per second, and then PYB, this is it, it's 34,500 kilogram meters per second. So the momentum, the net momentum in the y direction is positive 34,500 kilogram meters per second. So we're done with part A, but we still have to complete part B. Part B is just telling us the we have to backtrack a little bit. This is not the net momentum. This is the component. This is the component, not the net momentum. The net momentum was the question in part B. What's the magnitude and direction of the net momentum? So this is the momentum in the x, the net momentum in the x, and the net momentum in the y. And then part B of the problem, we want to find the magnitude and direction, magnitude and direction of the net momentum. Remember, we're calling the net momentum P. If you go back, just calling it PAB. Okay, so PAB, and the formula for that is simply you take the square of the total momentum for A squared, and then you take the square of the total momentum B squared, and then 2 times momentum of A times momentum of B, cosine of theta. Theta happens to be if the sedan is moving upwards and then the pickup truck is moving towards the right, it means that the angle between them is 90. So theta is 90. Okay, so then if we plug in the numbers for the net momentum for A, we get 35,000 kilogram meters per second. We want to square that, and then for B we get, well, actually remember it wasn't just 35,000, it was negative 35,000, so we have to recall that. But eventually when you square that, you'll see that it's gonna be the negative will disappear. So this is kilogram meters per second. That's the square of the momentum for B, and then plus 2 PA PB cosine 90. Okay, remember cosine 90 is 0. Cosine of 90 is 0. And so if we sum this up, we end up getting 49,000. We get 49,145. We'll just have that a little bit, go back a little bit. Okay, we'll just go back a little bit. See, this is 49,145.19 kilogram meters per second. In terms of direction, remember the sedan, if we go back, sedan is going upwards, and then the pickup truck is going towards the left. Sedan is going south north. Pickup truck is going east west, and they have a 45-degree resultant with respect to the north axis or the y-axis. So we'll say that the direction of the pickup truck, or rather of the net momentum, not the pickup truck. Now we want to be careful with that. The direction of the net momentum is northwest, and that happens to be 45 degrees. That's our problem for you. Hope you enjoyed it. Feel free to send questions or comments my way, and make sure you have a wonderful day. Okay, thanks. Bye.